Um, Hello, Dr. Manjeevan. Um, I will be going over my decision trees, my classification part for my assignment, and I'd like to start off with the first model that I have created. It is the decision tree. So if we look here, I have created a basic decision tree, and here is the decision tree that has been produced. We can see that it is fairly readable and it looks pretty good as it is. So we move forward and we test the model, and so we predict some values. So we predict the values against the test data that I have created earlier on in my assignment, and we create a confusion matrix from which we can see that the accuracy of the model is 82.51%. So what we do next is we try to increase this accuracy by changing the parameter. So we do this by setting the tune length to 10 at first. So when we plot the graph, we can see that the highest, like the best accuracy occurs at 0.00, which really doesn't mean anything. So what we do is we create the model again with the pruned tune length of 10, and we can see that the tree is very difficult, very large, and just impossible to read too many variables. So we check its accuracy. We see that it is 80.87% accurate, meaning it is lesser than the original model. Next, we set it to 5, the tune length, and then we see that the best tune occurs at 0.009, so very early on, somewhere around there. And we create the same model tree, and we see that it's very similar to the original model that we created. And we can see that the accuracy for this one is also 82.51%. So really it tells us that this is the best accuracy we can achieve with the current parameters. So next we move forward to the random forest tree. So first of all, we start off with creating a random forest tree with 500 trees, and we can see that the the out of box error rate is 13.33%, which tells us that the accuracy is roughly 86.67%, something like that. Next, we try to prune this tree by reducing the number of trees, try to see that if the accuracy increases, and we can see that the error rate goes down from 13.33% to 13.2%. So it shows that it has improved slightly, but it shows improvement. Next, we do an importance diagram. We can see that which variable affects the accuracy the least. So we can see that resting ECG and fasting BS. So resting ECG is 9.00 and fasting BS 9.65. So that's how much it. So that's how little it affects the accuracy. Whereas we can see that the one that affects the accuracy the most is ST slope. So it stands at 81.53%. So what we do is we create a little plot, and we can see that the red line tells us that the error rate when declassifying observations are 0, and the blue line shows us when the error rate classifying for the observations of class 1, and the green line shows us the out of bag error rate overall. So in general, we can see that our error rates decrease as the number of trees increase, and we can also see that the gradients more or less become flatter. So if we were to add more trees, so here we see 400, if we were to add maybe 1,000, it would most likely also be flat, and they would show no improvement. Furthermore, we see the accuracy of the model to be 83.61%. Sorry, 83.06%. I have to correct that. And so we further move on to using cross-validation to find the accuracy. And moving forward, we can see that the accuracy actually increases at mtry to 80 at mtry level 2 value 2. So we can see that it increases to 86.2%. So that would be the end of the video, and I hope it was easy to follow along. Thank you.